Welcome to Intro to Euler's method. So the idea here is we want to approximate solutions to initial value problems. So we want to approximate solutions to initial value problems, or IVPs. And what we'll do is we will start at the initial condition and then essentially do little mini stepping stones. So we'll start with the initial condition. And then do little steps. And we'll do the little steps by using tangent line approximations. So we're going to go ahead and do one of these types of problems by hand, and then later I'll show you how to use Excel to do these numerical approximations. So let's go ahead and start off with the IVP. Y prime plus 2y is equal to 3x squared e to the negative 2x, with y of 0 equaling 2. Our job is to approximate y of 0.5 using Euler's method and steps of size 1. So I haven't really explained Euler's method. We'll go through that right now. So first, I'm going to rearrange our equation. So rearrange the differential equation into the format y prime equals. So our differential equation would become y prime is equal to negative 2y plus 3x squared e to the negative 2x. Now we're going to start at the initial condition, 0, 2. So we'll start with the initial condition. Y of 0 is equal to 2. Then we're going to find the tangent line approximation at the point 0, 2. So for the tangent line approximation, we need a point and a slope. So we have the point 0, 2. And then our slope is y prime is equal to negative 2 times 2 plus 3 times 0 squared e to the negative 2 times 0, otherwise known as negative 4. So the tangent line approximation we would have y is approximately our initial y value, 2, plus our slope, -4, times our new x value, x, minus the initial one, 0. And now we are going to move by our recommended step. So if we look at the initial problem, we are asked to consider steps of size 0.1. So we are going to look one step past that initial x value of 0. So from here, now we are going to use the tangent line approximation. To estimate y of 0 plus 0.1. So this was our initial x value plus our step size. So we just found our tangent line approximation. So if we plug in, again, 0 was our initial x value. And 0.1 was our step. So if we plug in 0.1 now, we're looking at y of 0.1 is approximately 2 plus -4 times 0.1. And so we get that it is approximately 1.6. So now we have a new point. So now we will use the point 0.1, or y of 0.1 is 1.6 as our initial condition. And we'll just cycle through the steps we were just using. So now we need to do the tangent line approximation for the point 0.1, 1.6. So we'll find the tangent line approximation. At the point 0.1, oops, 0.1 comma 1.6. So our point we have 0.1, 1.6. Our slope, we will once again need to use our differential equation. We have that y prime was equal to -2y plus 3x squared e to the -2x. So y prime is -2y plus 3x squared e to the -2x. So we have, if we plug in 0.1 and 1.6, y prime is equal to -2 times 1.6 plus 3 times 0.1 squared times e to the -2 times 0.1. And if we plug that into our calculator, we wind up getting that y prime is approximately -3.1754, and then it keeps going with more digits. So our tangent line approximation we are looking at y is approximately our initial y value, 1.6, plus our slope, -3.1754, times our x value minus the initial x, 0.1 in this case. So now we will use the tangent line approximation to go one more step. So this time we are looking for y of 0.1 plus another 0.1, or y of 0.2. And this will be approximately, we have 1.6 plus negative 3.1754. And then we will be multiplying by 0.1. When we use our approximation to just go 0.1 further each time, we'll always be multiplying by 0.1, since the new x value minus that previous one are just 0.1 apart for a step of 0.1. So plugging this into our calculator, we wind up getting approximately, or y of 0.2 is approximately 1 point, oh, sorry, I apologize. I typed something in wrong. All right, now with the correct number, we have y of 0.2 is approximately 1.2824 ... I'm just keeping these numbers in my calculator as I go, so I'm not rounding until the end. So from here, we will now use y of 0.2 equals 1.2824 ... as our initial condition. And we'll keep going from there. So to find our tangent line approximation, we will have a point of 0.2, comma, that 1.2824 found previously. Our slope, we will once again plug into y prime is equal to negative 2y plus 3x squared e to the negative 2x. So we have negative 2 times that 1.2824 plus 3 times 0.2 squared times e to the negative 2 times 0.2. Plugging that into our calculator, we wind up getting this is approximately negative 2.4844, and then more digits to follow. So our line, our equation, would be y is approximately our initial y value, 1.2824, plus that slope, negative 2.4844, times x minus 0.2, our current initial x value. So now we can approximate y of 0.3. That's one more step down the line. All right, we did 0.2 plus 0.1 to go one step further. So approximating y of 0.3, we have y of 0.3 is approximately 1.2824 plus negative 2.4844 times 0.1. And plugging that into our calculator, we get that this is approximately 1.0340 with more digits to follow. So now we will use y of 0.3 equaling 1.0340 as our initial condition. And we'll just repeat these steps. So this step will get us to 0.4, and the next step will finally get us to that 0.5 we were looking for. So we have our tangent line approximation. We have a point of 0.3, 1.0340. For our slope, we will once again use the fact that y prime is equal to negative 2y plus 3x squared e to the negative 2x. So we are looking at y prime is equal to negative 2 times our 1.0340 plus 3 times 0.3 squared times e to the negative 2 times 0.3. Plugging that into our calculator, we get our slope is approximately negative 1.9198. Continuing on, our equation is therefore y is approximately our initial y value of 1.0340 plus our slope negative 1.9198 times x minus 0.3, our initial x value here. From there, we'll go ahead and approximate y of 0.4, our next step down the line. So we have y of 0.4 should be approximately 1.0340 plus negative 1.9198 times 0.1. 0.4 minus 0.3 is at 0.1. And this gives us y of 0.4 should be approximately 0.8420 . From there, now we are going to use this as our final initial condition. So we'll use y of 0.4 equaling 0.8420 as our initial condition. We will then find our tangent line approximation. So we have a point of 0.4, 0.8420. We have our slope. Again, we'll use the equation y prime is equal to negative 2y plus 3x squared e to the negative 2x. Plugging in, we are looking at negative 2 times 0.8420 ... plus 3 times 0.4 squared times e to the negative 2 times 0.4. And if we plug this into our calculator, we get that y prime is approximately negative 1.4683 dot dot dot. And so we have our equation would be y is approximately our initial y value 0.8420 dot 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 plus our slope negative 1.4683 dot 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 times x minus 0.4. So now at this point, we can finally approximate y of 0.5. And so if we plug that into the most recent equation, we have y of 0.5 should be approximately 0.8420 plus negative 1.4683 dot 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 times 0.1. And we get that y of 0.5 is approximately 0.6951. And then there's more digits after that. So I did not round anywhere in this problem. The dot dot dots, all of that was stored in my calculator. I could go out more digits at this point if I so choose. But this is using Euler's method by hand. As you can see, it's very lengthy and we only went 5 steps. So if you wanted to go farther, it would take a lot more time.